Hi, hello. Good morning, everyone. Hi, students from JNV. DU. How are you? If it is convenient, means do text me in a chat box. Okay, whether I'm an audible or not, or else you can. No, there is no pause. No problem. Okay, do text me in a chat box, guys. I'm an audible, right? Within 2 to 3 minutes, we'll start our session. Today's one. Myself, Sham. Okay, I'm from Karnataka. Let us wait for further 2 to 3 minutes, guys. Okay, within 2 minutes, we're going to start our today's session. Hey, hi, good morning. Ashlesha. Yes, good morning. How is everything is going on? How is your preparations? Is it good? Say the problem. Yes. So the problem nine. Just 2 minutes. Okay, let us start our today's session. Already I introduced myself. This is Sham. I'm working as a program associate in Avantifellows at JNV Haveri. It's in Karnataka. Behalf of absence of the Vivek, I'm engaging this class. Yesterday also I engaged. Sorry for the YouTubers. Yesterday class YouTube में नहीं आया था. Okay, quite. I think since last day we faced so few technical errors in our YouTube. That's why we can't able to come in a YouTube live stream. Okay, कोई तो problem नहीं. We are going to upload that video very soon in a YouTube in the same link. May I know how many of you will come in a Saturday and Sunday session for this class? If it is convenient, means please do text me in a chat box. Feel free to text me. Hey, okay, Gnani. Hi, good morning. You are the regular student then. Cool. Okay, no problem. Actually, we started rotational motion yesterday class, correct? Now, in yesterday class, we discussed few things. What are the things which we discussed? I'm going to quickly explain that one. Okay. First thing we discussed about the system. A system क्या होता है? Correct? Now, I told you that these are the particles. Means these particles, if you want to collect n number, means this is a system. Correct? Now, collection of n number of particles we call as an system. Correct? Now, each particle have a mass. I called m1, m2, m3, like that. N number of particles are having mass up to mn. Correct? Now, this all particle mass is concentrated at any one point. At any one point, this is an imaginary point. Where it is located, we don't know. Correct? Now, this is an imaginary point. We call this imaginary point where all the mass of the system is concentrated is called center of mass. Correct? Now, this is also we discussed. And later on we discuss one more point. If you're going to apply the force on this object, force apply करने से, there are two kinds of motions are possible. There are two kinds of motions are possible. First one is that translatory motion, correct ना? First one is translatory motion. Second one क्या है? Rotational motion. Rotational motion. So two things which can be takes place by the application of this external force, correct now? And during the translation motion होना चाहिए means force को किधर apply करना पड़ता है? Is anybody tell me in a chat box where we need to apply the force to make the body or system translatory motion? Where we need to apply the force? देखो इधर मेरे पास एक, हाँ, this is a stick, okay, uniform stick. The mass is distributed over the stick is uniform. बड़ा थोड़ा बड़ा तो ले लो, ओके ले लिया मैंने, थोड़ा सा बड़ा, ओके इसका सेंटर ऑफ मास इधर है. यूनिफॉर्म मींस at the geometric center it will be center of mass is located, correct now? Okay, then tell me in which point if you're going to apply the force, then this rod will move uniformly. 3 points are there, A, B, C, A, B, C. In which point you need to apply the force to make this rod uniform motion? Sorry, not uniform motion, straight line motion. Okay, Gnani, good. Yes, you are right. क्यों ना? If you're going to apply the force exactly at the center of mass, exactly at the center of mass, the body will move in straight line. Instead of you applying the force at B, if you are going to apply at C means क्या होता है? It will start to move in this direction. Or else if you're going to apply the force at A means it will start to move downward direction. Means rotate होने के start होता है. Correct ना? Means you need straight line motion और translatory motion करने के लिए force को किधर apply करना पड़ता है? Center of mass. Cool. Yes. Right. Good. Yes, this is also we discussed, and later on what we discuss next thing. Yes. If the object is moving means the position is continuously changing. Position के लिए एक equation लिखा था हम, correct ना? With respect to the center of mass. What is that? RCM is equal to center of mass of the position. Okay, is equal to M1 R1 plus M2 R2 plus M3 R3 plus so on up to n number of particles are there, correct na? We need to do like this and divided by M1 plus M2 plus M3 plus so on M1, correct na? This is for the regular one, means general equation likha tha, correct na? This is a general equation. Okay, in particularly along the x-axis I told you that if you are going to take this as system means, okay, इसमें n number of particles are present. Okay, इस system में center of mass find out कर लो x-axis में, y-axis में, like that they might be asked the question. They're going to ask the question like that along this, suppose इधर center of mass है, correct ना? Now tell me that center of mass where it is located along the x-axis, along the y-axis, like this they might be asked, correct now? If at this situation what you need to do, similar equation you need to write in a x and y term. X center of mass क्या होता है? M1 x1 plus M2 x2 plus M3 x3 plus so on divided by M1 plus M2 plus M3 plus so on. We can write this M1 plus M2 plus M3 as a capital M. Capital M represents the total mass of the system. Clear? Similarly, you need to write for the Y center of mass along the y-axis in on which point the center of mass is located. Cool. This is also a way to find out this one, correct now? And for the two particle system, For two particle system, we find the center of mass, correct now? This is of mass 1, this is the second mass 2, they are separated by a distance. Hey, क्या हो गया? Extra हो गया distance. Okay, कोई problem नहीं. They are separated by a distance d. Okay, now tell me that where the center of mass will be exist. Where the center of mass will be exist? Yes, near the heavier mass. Correct now? Means from the mass 1 to this is the center of mass, means what will be the distance is there? No, we call this one as a d1. From center of mass to second mass tak hai na distance, we call this one as a d2. By using these two condition, we find out the d1 and d2 values. Correct now? D1 is equal to m2d divided by m1 plus m2. Second one, d2 is equal to m1d divided by m1 plus m2. These are the two equations which we find in last class. Correct? Am I correct? Right. Later on, what we discussed, based on this one, if the position is moving, okay, object is moving means uska center of mass ko kaise dikhta hai, we already know, right? Now itself r cm is equal to, for two particle system I will write simply r m1 plus m1 r1 plus m2 r2 plus so on divided by capital M. I will write simply. It's a mass of whole the system. Take this mass to left hand side, means m r cm is equal to m1 r1 plus m2 r2 plus so on. R है ना, ये position होता है. If this position will be changes with respect to the time, okay, means simply if you're going to differentiate this one, means क्या होता है, after differentiation of position velocity आता है, correct ना, then it can be written as m v cm left hand side on differentiation is equal to m1 v1 plus m2 v2 plus m3 v3 plus so on. This is what the velocity of the center of mass. Okay, you can find out the velocity of center of mass by using this equation, depending upon the particles, how many particles are there. Okay, थोड़ा देर से गो से देखो इधर, m into v, it is nothing but momentum. p cm हो गया, right hand side में p1 plus p2 plus p3 plus so on. Correct now? Now coming to the next one. This is equation number 2, I will call this is equation number 1. If first I differentiate the equation number 1, we got velocity equation number 2. If you want to differentiate again the velocity equation, means you will get the acceleration. Correct ना? Acceleration equation क्या होता है इधर? m v को differentiation करने से acceleration मिलता है, center of mass is equal to m1 a1 plus m2 a2 plus so on. करेक्ट ना? देखो इधर क्या मिल गया, फोर्स. करेक्ट ना? लुक एट हियर, इफ यू अप्लाई द फोर्स ऑन द सेंटर ऑफ मास, the body will make translator motion along with the parameters whatever we find out now. It is exactly right. Here it will become f1 plus f2 plus so on. Correct now? Okay. No worries, I will send you this notes also in a group. Okay, seed group में है ना आप? Okay, I will send you the notes in a seed group. Okay, no worries. Cool. This is all about what we discussed in the last class. Okay, coming to this class, today's class especially, right? I already told you translatory motion is a secondary point. Okay, now if you're going to apply the force apart from the center of mass, देखो इधर, this is a linear object what I took for the best example I took here. Correct now? This is the center of mass. Oh, क्या कर रहे हैं यार? Who is this? Don't do like this, yaar. Okay. Notations बहुत ज़्यादा वो है इधर. Guys, don't do screen annotation here. I hope it is by mistake happened. Okay, don't do like this. Look at how the page is looking now. Cool. कोई तो problem नहीं. Okay. Now I had told you that if you're going to apply the force on the center of mass means the body will move in a translated motion. Okay. What if you're going to apply the force at this position means क्या होता है? The body will start to move like this. Means थोड़ा सा rotation होता है. Correct? Means apart from any point from the center of mass, if you're going to apply the force means the body start to rotate. The body start to rotate. ये rotation motion में क्या क्या चीज सीखना है? I will explain first. Okay. First thing, we'll take our rigid body. कॉन्सेप्ट तो रिजिड बॉडी है ना, इसलिए मैंने रिजिड बॉडी ले लिया. रिजिड बॉडी में बहुत सारे पार्टिकल्स होता है. आई एम गोइंग टू कॉल m1, इधर से ये m2, इधर से m3, करेक्ट ना, ये तो m4. ओके, लाइक दिस n नंबर ऑफ पार्टिकल्स आर देयर. वो सभी का सभी पार्टिकल्स का सेंटर ऑफ मास मान लो इधर है. किधर? येलो कलर में मेंशन करता हूं मैंने, इधर है. दिस इज द center of mass. Now if you want to rotate this rigid body means you need to consider one axis. About an axis only it will rotate, correct na? One imaginary axis chahiye humko. I will consider one axis here. Just imagine this is the axis passing through the this system. Okay, this system. What I will do, center of mass idhar hai. I won't apply the force on the center of mass. Instead of that, I will apply the force on this body here. Kaise? Yes, dekho idhar. This is one of the rigid body. Correct na? This is the rigid body, guys. Right? If you are going to apply the force on the center of mass means it will move translated motion. Instead of that, if I'm going to apply the force on this end means it will start to rotate. Correct now? This is what I'm explaining here. Right? Meanwhile, if you're getting doubt means please drop your doubt in the chat box. Cool. Okay. I'm applied the force other the point than the center of mass here at this particular condition. क्या होता है? From this, with this axis, the body start to rotate. Right now, the body start to rotate like this. Rotate. घूमने के लिए start होता है. किधर? City घूमने के लिए नहीं होता है इधर. Just it will be rotate around the axis, like हमारा धरती माता के तरह. Okay. Okay. Now consider. देखो इधर. I'm going to take one more center of mass here. Sorry, a system of body. Okay, this is actually, yeah, क्या हो रहा है इधर? If you're getting bored means please do tell me. I will explain. I will tell you one story also. I'm a good storyteller. Okay, this is the axis. Consider करो इधर एक body है, ये position में ये में. Okay, I won't write m1 and 2. ये पार्टिकल इधर है. नेक्स्ट और एक पार्टिकल है बी में. ओके, नाउ ड्यू टू द एप्लीकेशन ऑफ फोर्स, if the body A will be particle A will move in this direction like this, correct now? B also move in this direction. Now like this, if they are moving means they might be making one concentric circle like this. B also poses one concentric circle around the axis of rotation. Correct now? If suppose consider मान लो इधर ये reach हो गया point A dash पर, उस समय from A to center of axis एक distance था ना, we call this one as position R, and this R1. From A to B it is R2. Okay, now from A to A dash, this is also R1 only. from A to, sorry, axis to B dash तक आता है ना particle, वो भी R2 है. Correct now? Means the particle is, what is doing here? It is making concentric circle. Means circular motion कर रहा है इधर. Correct now? Now we need to analyze that when a system which is moving in a circular path or it is rotating about its axis, means the each and every particle of a system makes concentric circles. Correct now? Here this radius vectors are there, no position vectors, they are making angle theta, means they're creating some angle theta here. It is all correct. Now we need to analyze for each and every particle what will be the angular displacement, what will be the angular velocity, what will be the angular acceleration, what will be the linear momentum, and as well as the relation between linear momentum and angular momentum. Correct? These are all the things which we need to find out first for the rotation of a rigid body. Later on we need to find out the center of mass by using that, or moment of inertia, like that quantities. Correct ना? मालूम हो गया ना क्या हो रहा है इधर? I will explain once again. If you consider this is a system में n number of particles are there. I consider only two particles here, A and B. Due to the application of force, those two particles start to rotate about its axis, making concentric circles. Depending upon their position, the radius vector will be increases. There is no problem. Correct now? देखो इधर one more point. A to A dash, a particle which is moving means it describes an angle theta. Correct now? Similarly, B to B dash, another particle also moving, it is also describing an angle theta. Same angle they are going to describe. देखो इधर सुनो, it is very important. From this axis, if we want to consider the origin, means point A to A dash, if a particle which is moving means it describes an angle theta है ना, the same angle which is described by the particle B from B to B dash, angle तो same ही होता है, but speed of a particle is there, no speed which is okay. May I know which particle have a more speed here, particle A or particle B? बता दो इन chat box में. Those who are watching in a YouTube, you people can also drop your answer in a chat box. Which particle having more speed, particle A or particle B? No worries, if it is wrong means there is no problem. This particle B has more speed. It has more speed because it covers maximum distance compared to the A particle. Cool. Correct now? Yes. Right. Next, coming to the system again. If the particle M1 say up to center of axis, the distance is there. No, I will call this one R1. Okay. And from the particle 2 to center of axis R2, from 3 to center of axis R3, from 4 to center of axis R4. These are the positions which are present inside the system. If they start to rotate means they describes each and every particle describes equal angular displacement, but speed of each particle will be different. This is the conclusion. Hope it is understood. Let me know through the chat box. Is it understood right? Okay, let us discuss one by one. Actually, this is actually you already know this one in center of mass, sorry, circular motion. who is this yaar? I don't know who did this one in on the screen. Just a minute. Just a minute. Okay. Everything is cool. No, देखो इधर same. I'm considering only one particle. Okay, one particle is there in a system. Okay, if the particle making concentrated circle means, look at here, from P to Q it is moving. Particle A which is moving from P to Q, it describes linear displacement, yes, and angular displacement to theta होता है, the due to the radius of this curvature. Correct now? Here you need to find out the value of theta means how you are going to find out it. Actually आपको एक पता एक रिलेशन है ना सॉरी मैथमेटिक्स में आर्क लेंथ को कैसे देगा. how you are going to represent the arc length? Arc length is there nothing but, yes, okay, P to Q displacement is equal to angle into radius of that circle. Correct now? From this equation only we are writing that theta value. Theta means angular displacement hota hai idhar. Theta is nothing but angular displacement. Angular displacement ko equation kya hota hai? Linear displacement by radius. Just rechange this one. S is equal to theta r hai. Theta if you want to define theta means take r to left hand side, then S by r is equal to theta. Correct now? Right? This is the angular displacement which is possessed by the particle in a system. Okay, what is the SI unit for this one? SI unit क्या है थीटा को? SI unit होता है रेडियन. Okay, डायमेंशनल फार्मूला क्या होता है? देखो इधर डिस्प्लेसमेंट है ना न्यूमरेटर में, डिस्प्लेसमेंट which is measured in meter. करेक्ट. रेडियस विच इज आल्सो मेजर्ड इन मीटर. दोनों आपस में कैंसल हो गया. देयर इज नो डायमेंशन फॉर दिस रेडिएशन, सॉरी दिस एंगल. करेक्ट ना? डायमेंशनल फॉर्मूला नहीं है. कूल. Okay, next coming to the point. Okay, one more point I want to tell you here. No problem, it is cool. Angular velocity कैसे दिखता है इधर? आपको पता है ना linear velocity, change in displacement by time. Linear velocity, we will write linear velocity is equal to change in displacement by time, change in time. Similarly here also you need to write the same thing. Actually linear velocity क्या होता है इधर? जस्ट अ मिनट. एंगुलर वेलोसिटी है इधर. इधर क्या लिख दिया मैंने? एंगुलर डिस्प्लेसमेंट लिख दिया है. थोड़ा सा कंफ्यूजन है, काट करो. ओके, वेलोसिटी लिखो. दिस वन इज नथिंग बट वेलोसिटी. कौन सी वेलोसिटी? एंगुलर वेलोसिटी. ओके, चेंज इन डिस्प्लेसमेंट मींस हियर थीटा 1 to थीटा 2 लाइक दैट. ओके, देखो इधर सर्कल पॉइंट P है, Q है, और एक पॉइंट R पर आता है पार्टिकल. एट द टाइम इट डिस्क्राइब्स एन अनदर एंगल. करेक्ट ना? फ्रॉम हियर टू हियर इफ यू गोइंग टू टेक थीटा 1, फ्रॉम हियर टू हियर इट इज थीटा 2. टू डिस्क्राइब एंगल थीटा 1 it takes time t1 and t2. Similar way you need to write. There is no change. Okay, but angular velocity we are representing here with the letter omega. Omega is the angular velocity, right? Angular displacement क्या value? Delta theta by delta t. If you write means it is enough. Delta theta divided by delta t. Okay, this is the value of average one. If you want to write this one in an instantaneous means apply limit delta t tends to 0. It will become d theta by dt. Okay, nothing. I'm just defining the parameters of motion here for this circular motion. Clear enough? There is no hectic things here. Next thing is angular acceleration. Means the same particle in a system. एक पार्टी सिस्टम है ना, देखो देखो देखो, ये सिस्टम है, इट इज रोटेटिंग अबाउट इट्स एक्सिस, मास m1 है, इधर मास m2 है, ओके, m1 which is moving or creating a concentric circle here means with respect to the radius, okay, इसके पास acceleration भी होता है, but acceleration is nothing but here angular acceleration, that is alpha, okay, उसको define करना है, change in velocity by change in time. Which velocity? Angular velocity. ठीक है ना? Okay. One more point I forgot to explain here. What is the SI unit for this one? Angular velocity के लिए SI unit क्या होता है? SI unit. Is there anyone tell me in a chat box? What is the SI unit for angular velocity? Those who are watching on YouTube, you may also drop your answer in the chat box. What is angular SI unit for the angular displacement नहीं है, velocity? Good morning, Yogesh. SI unit क्या होता है यार? इधर देखो, थीटा को रेडियन है ना, करेक्ट, रेडियन डिवाइडेड बाय टाइम है, टाइम तो सेकंड में होता है, रेडियन पर सेकंड इज द एसआई यूनिट फॉर वेलोसिटी। डायमेंशन फॉर्मूला क्या होता है, रेडियन को कोई भी डायमेंशन नहीं है, व्हाइल राइटिंग द डायमेंशन वी आर राइटिंग एम एल टी, मास तो नहीं है जीरो, लेंथ है क्या नहीं है जीरो, yes means time, it is in denominator, if it is comes to numerator means -1, this is the dimension formula for velocity. Tell me for the angular acceleration, SI यूनिट क्या होता है, पहला क्वेश्चन, SI यूनिट ऊपर तो रेडियन पर सेकेंड, ऑलरेडी वी डिसाइड, करेक्ट ना, रेडियन पर सेकेंड फॉर द वेलोसिटी, डिनोमिनेटर में और एक चेंज इन टाइम है, मींस टाइम इज देयर, अगेन टाइम, इट विल बिकम रेडियन पर सेकेंड स्क्वायर, dimension formula again m, there is no mass, there is no length, and time तो power 2 है, if it is comes to numerator -2 होता है, this is for the dimensional formula of angular acceleration, correct ना? Okay, one more point, I think you know this one, correct ना? We know when acceleration is constant, we are going to define or derive three equations of motion, correct ना? V is equal to Oh shit. Sorry. Now I'm audible, right? Am I audible? Sorry, mute हो गया था. Okay, what is the correct answer for this question? The angular velocity of second hand watch will be. Angular velocity को पता करना है. Angular velocity को equation क्या होता है? लिख लो. Angular velocity is equal to change in displacement divided by change in time. करेक्ट ना. डिस्प्लेसमेंट कितना होता है? लिख लो. सेकेंड हैंड वॉच में डिस्प्लेसमेंट, एंगुलर डिस्प्लेसमेंट फॉर वंस कंप्लीट रोटेशन कितना होता है? 2 पाई इज द रोटेशन एंगल. नो, 2 पाई इज द रोटेशन एंगल डिवाइडेड बाय टाइम. कितना लगता है वो रोटेशन के लिए? सेकेंड हैंड 60 सेकेंड्स तो है ना, राइट? 2 1 जा 2 30 जा. ए सुपर सुपर, बट थोड़ा सा मिस्टेक हो गया. कोई प्रॉब्लम नहीं. देन इट विल बिकम pi by 30 रेडियन पर सेकेंड. कोई तो प्रॉब्लम नहीं. This is the angular velocity. Okay. Those of feeling, sir, you didn't give a time to solve this one. No, I will give time for you all to solve the next question. Okay. Next question भी इधर है, but don't look at the answer. Actually answer भी है इधर. Highlighter यूज करना है. Shit. किधर है highlighter? पता कर दो आंसर. आई नो यू कांट प्रेडिक्ट. आंसर भी इधर आ गया है, क्या करना है मुझे? कुछ try it once. Those who didn't look at the answer, no, please do solve this one and let me know which is the correct answer. I will give you exactly 2 minutes of time. After this problem, I will tell you that I'm going to give you 2 problems which are very important and they are very good. Okay, we'll solve that one. Find the answer for this question. Sure. Sorry. Either कुछ भी नहीं. Angular linear acceleration, how you are going to define? Change in velocity by time? No, it's a linear one. Similar way, you need to write this one in a angular term. Angular term means a instead of you need to write alpha. Okay, v के बदले you need to write omega. Correct now? This is the angular acceleration. But the interesting thing is that they didn't give the value of omega here. Correct ना? They given theta value. Solve कर दो. Solve करो. हो गए क्या? अरे यार, कितना इजी का है। एंगुलर एक्सीलरेशन के लिए फार्मूला क्या होता है इधर, राइट? एवरेज के लिए डेल्टा ओमेगा ले लो, और एल्स यू कैन टेक डी ओमेगा बाय डी टी। बट ओमेगा तो नहीं है ना, दे गिवन द वैल्यू ऑफ थीटा। थीटा वैल्यू कितना है? ए टी प्लस बी टी स्क्वायर प्लस सी टी क्यूब, करेक्ट ना? मीन्स इधर दिस इक्वेशन रिप्रेजेंट्स दैट गाइस, दिस द एंगुलर डिस्प्लेसमेंट है ना, ये चेंज हो रहा है विथ रिस्पेक्ट टू द टाइम द गिवन, करेक्ट ना? मीन्स वी नीड टू डिफरेंशिएट दिस वन फर्स्ट। वी नीड ओमेगा, राइट? ओमेगा चाहिए, मीन्स थीटा को क्या करना है? डिफरेंशिएट करना है। डिफरेंशिएट करो एक बार। डी थीटा क्या होता है? डी थीटा अपॉन डी टी, इट विल गिव ओमेगा, नो? ओमेगा चाहिए मीन्स इसको डिफरेंशिएट करना है। ये को इक्वेशन डिफरेंशिएट कर दो विथ रेस्पेक्ट टू टाइम। ए टी विल बिकम ये प्लस बी टी स्क्वायर विल बिकम 2 times the bt plus ct cube will become 3 times ct square, correct na? Now we got the equation for omega, correct na? ओमेगा के लिए इक्वेशन मिल गया, एंगुलर वेलोसिटी, बट it is not yet completed. We need to find out actually acceleration. Then put this omega value in this equation. Then alpha value क्या होता है? Alpha is equal to d by dt of omega. Omega क्या है इधर? ये plus 2bt plus 3ct square. Correct ना? This is what the omega. Now क्या करना है? Again we need to differentiate this term with respect to the time. Then it will give angular acceleration. Alpha will be equal to, yeah, we'll check. Angular acceleration alpha will be equal to, ये तो कांस्टेंट है, कांस्टेंट इनटू एनी डिफरेंशिएशन 0 होता है, करेक्ट ना? देन 2bt is there. If you differentiate 2bt means you will get 2b plus here 3ct square is there. If you differentiate this one means 3 2s are 6 into ct. This is what the angular acceleration. Angular acceleration मिल गया. Then which is the correct option among these four? Just you take this option number D as a correct. Correct है ना? Sometimes what they will do, no? After then in the last they will give, okay, no problem, time value and A and B value also they set there. Just after that you put these values A, B, C in the last and you will get an answer also. Some other answer which is present. Hope it is understood, right? Is there any doubt? Right, Jane Chengbang, right answer. Good. Yes. Okay. If it is understood means we'll move towards next one. That is very important thing in this chapter. Just a minute, just a minute. क्या हो गया यार इधर? टॉर्क के लिए जंप हो गया. ओके, देखते हैं क्या मिलता है इधर. टॉर्क मिलता है यार, कुछ मिलता है. ओके, देखो इधर. दिस इज द सिस्टम, करेक्ट ना? दिस इज व्हाट इज सिस्टम ऑफ बॉडी. सिस्टम थोड़ा सा डिजाइन करते हैं सिस्टम. ओके, सिस्टम है, इसके पास n number of particles are there. कितना particles are there guys? n number of particles. I will take only 2 particles, m1 m2. Okay, during the rotation we are considering here one axis. About the axis only the body will start to rotate like this. From the axis to mass m1 the perpendicular distance r1, mass m2 perpendicular distance is r2. Okay, here we define theta value, omega value and alpha value also. What if is this possessing any momentum? Momentum भी होता है क्या इसके साथ साथ? Obviously होता है. Actually we know how to define the momentum. Guys, do you have any idea about momentum? Linear momentum, p वाला quantity. How we are going to define this quantity? P. Momentum will be equal to, yes, mass into velocity होता है, mass into velocity होता है, correct ना? Yes. Now we need to define, this is a linear momentum when body will move in a straight line. This is for straight line. Okay, but the thing is that here the body possessing angular momentum, angular momentum को हम लिखते हैं like this, angular momentum is equal to, the value of angular momentum we are representing with capital letter L, okay, is equal to, actually it is product of linear momentum with respect to multiplication of perpendicular distance r. r क्या है? पोजीशन वेक्टर which is rotating, करेक्ट ना? उसको मल्टीप्लाई करते हैं. कैसे सर? आई विल गिव यू वन एग्जांपल, आई विल गिव यू वन एग्जांपल. आपको पता है ना what is the relation between linear displacement and angular displacement? That is s is equal to r theta ना. Now only we solve this one. Displacement हो गया. What is the relation between linear velocity and angular velocity? r omega. This is also known in circular motion. What is the relation between linear acceleration and angular acceleration? Means r alpha, करेक्ट ना? इधर लीनियर टर्म को एंगुलर टर्म में कन्वर्ट करने के लिए क्या मल्टीप्लाई कर रहे हैं आप? क्या मल्टीप्लाई कर रहे हैं यार? r को मल्टीप्लाई कर रहा है, सिंपल सा बात, करेक्ट है ना? इधर भी वही तो सेम है. एंगुलर मोमेंटम को आई विल राइट एज एन p into r, राइट? आई होप इट इज अंडरस्टूड, करेक्ट ना? देखो इधर angular momentum is equal to p into r है, करेक्ट ना? p means we know that p is equal to m into v, mass into velocity. Here m stands for, guys, mass, v stands for velocity, correct है ना? Put this value in this equation, then angular momentum value will become p means mass velocity into r. But देखो L stands for angular momentum, guys. M stands for mass. R stands for radius or position vector of the particle. V stands for velocity. But velocity, it is a linear velocity. That's why we need to write this one in a angular term. Angular term means इधर है V का value, है ना? V का value क्या कितना होता है? देखो इधर, इधर देखो क्या है? V is equal to r omega. V is equal to r omega. No, substitute this value here. Then angular momentum value will become m into v means r omega into r है, correct? Now angular momentum will be equal to m r into r square, दो r है ना, into omega. Guys देखो इधर एक खूबसूरत का इक्वेशन मिल रहा है हमको, इधर मिलना वाला है. क्या है ना? L is equal to m r square omega है ना? इधर m r square is there, right? This is one of the physical quantity of the system. We call this one as an moment of inertia. क्या कॉल करते हैं इसको? Moment of inertia, which is represented with the capital letter I into omega. ये moment of inertia क्या होता है? I will explain. Don't worry. I stands for here moment of inertia, correct है ना? Moment of inertia. What is the value of I? Means I is equal to m r square. Okay, I will tell you what is this moment of inertia actually. आपको पता है ना न्यूटन्स लॉज ऑफ मोशन में इनर्शिया क्या होता है? जनरली इनर्शिया, 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 अनेस्थेशिया नहीं है, इनर्शिया. Inertia, it's an inherent property of an object, we will say, correct ना? Inherent property means suppose मान लो इधर एक ऑब्जेक्ट है टेबल के ऊपर, करेक्ट? टेबल के ऊपर ऑब्जेक्ट है. If you are not applying any force on this object means a object won't move at any point. It will be stay in the same position until you are applying an external force. Correct now? Similar way here also, this is the system. This is the system. Correct now? If you want to move this particle, means you need to apply the force to overcome the rest. Correct now? That is what the inherent property of this particular system. Correct? That is known as here moment of inertia. How much amount of force which is required to come out from the rest position for this object, that quantity is called the quantity which is measuring, which is called the moment of inertia. Hope you guys understood this one, right? Let me know in the chat box. Moment of inertia is nothing but overcome from the rest position. How much force it is required. Correct now? To calculate that one, to calculate that quantity, to calculate that one, we need one quantity. We call that one as a moment of inertia. Clear enough? Although, is it clear? Well, देखो देखो देखो, I will explain you in a detail. Okay, this is a system. Correct now? This is a system. Here I consider one small mass dm at a distance, perpendicular distance r. Actually, it is at distance. It is actually at rest. Okay, if you're going to apply the force on this object, means the body starts to rotate about its axis. Correct now? To make this rotation, whatever the force which is required, that is called the torque. Why we call torque? I will explain that one. To overcome this rest position to motion, it's an inherent property of this object. Correct now? That's what I call that. This is as a moment of inertia, mr square. Clear enough? If you want to write this moment of inertia for n number of particle, means I is equal to m1 r1 square plus m2, similarly like this, m1 m2 m3, m2 r2 square plus m3 r3 square plus so on. You can write like this. Okay, no problem. This is our equation for moment of inertia. Cool. Okay. Then it's cool. Moment of inertia. Okay, guys. If it is understood, means it is enough. Okay. I would like to ask one question from my side to all of you. Question is that, देखो इधर, it's very important. It's very important. इधर मेरे पास एक पुली है. Correct ना? This is a pulley. This pulley, on this pulley, I suspended two masses. M1, another one is M2. Two masses are suspended here. M1 is moving downward direction. M2 which is moving upward direction. M2 which is moving upward direction. Actually, this is a problem. This is not a topic. Problem है. Acceleration downward है. इसका acceleration upward. Okay. Then what will be the center of mass of acceleration? They might be asked. Means acceleration of center of mass को find out करना है. कैसे find out करना है? This is my question here. Okay, don't confuse with the capital letter. While explaining, I write here A C M. Correct ना? इसको calculate करना है for this system. Okay, if you're going to calculate this one, later on I will stop this session. Okay, सुनो इधर क्या हो रहा है देखो. सेंटर ऑफ मास फाइंड आउट करना है एक्सेलरेशन के लिए. इक्वेशन क्या बनता है? फर्स्ट हमारे पास पोजीशन था ना, m is equal to r cm is equal to M1 R1 plus M2 R2 plus so on. But here only two particle system are there. It is enough. Once if you are going to differentiate this one, no. Once differentiate this one, no, you will get velocity. Correct now. On further differentiation, you will get acceleration. Acceleration will be. Acceleration के लिए equation क्या होता है उस समय m into a cm is equal to m1 a1 plus m2 a2 होता है ना. Correct. I will give you the hint. Okay. I think time is up. Okay. I will give the hint how to solve this one. Solve this in home. Correct now. Cool. Either m means capital M is nothing but total system of mass. क्या होता है इधर m m1 plus m2 होता है into acceleration of center of mass find out करना है इधर m1 a1 correct ना which is moving downward direction इधर plus m2 है acceleration which is moving upward for the first system. If you consider for the first mass means second mass का acceleration upward direction इसलिए इधर क्या लिखना है acceleration को minus a2. Correct? Then it will become acceleration of center of mass will be equal to m1 a1 either minus m2 a2. We know one more point also. क्या लिखना है? Okay, I will give you one value here. If m1 equals to m2, take m1 equals to m2. No. Don't take m1 equals to m2. Okay, take acceleration will be equal here. For a pulley system here, acceleration क्या होता है? a1 is equal to a2 होता है. For a single pulley. For double pulley होता है तो single pulley को क्या होता है acceleration? उसका आधा होता है double pulley. Correct ना? इधर take a1 is equal to a2. Correct ना? Then left hand side में क्या था? m1 plus m2 था. Correct now. Then next ACM is equal to, I'm going to take this m1 m2 right hand side. Either a1 will be equal to a2 means it will become aa, take common as an a, then it will become m1 minus m2 divided by m1 plus m2 हो गया into acceleration आ गया. Okay, everything is okay here, there is no problem, but this is not an answer. Answer क्या है ना? The answer will become out when you need to find out the value of a and you need to substitute the value of a here. Correct? कैसे find out करना है a का value? Actually, write the free body diagram for this system. Okay, and find the value of a. Find value of a and substitute here. You will get the answer. Okay, cool. Right? This is a center of mass of acceleration for the center of mass mil gaya, but we need to find out the value of a and then you need to substitute here. Correct what I'm saying? This is a hint which I'm going to give you. Okay, solve this one. Solve this one. You will getting an idea about it. Okay, this is all about today's class, guys. Hope you all got this concepts what we are discussed. Okay, if you have any problem means do tell me in a chat box or else I will unmute you all. You can ask me. Okay, if you don't have any doubt means you can leave the class. No problem. This is all about today's class, guys. If you have any doubt means you can unmute yourself and you can talk. Okay, then if you don't have any problem means or doubt means we will going to see, I will see you in our next class, guys. Okay, until then, take care. Bye bye. Thank you so much. Bye bye, guys.